Hello everyone, I'm Narmatha, Assistant Professor working in Department of Computer Science with Cybersecurity in Dr. SNS College of Arts and Science. In today's lecture, we are going to discuss about semaphores in operating system. So mostly semaphores are used to synchronize the process. Here, most of the processes are executed in your CPU. You want to sync with other process means we'll use this semaphore concept. So what it does means it prevents a race condition while executing different process. A race condition means if more number of people are using shared resource and they are updating at the same time means this race condition will occur. For example, I'm having a file, so that will be shared in a path. So two, three members are at a time updating that same file means no updations will be updated in that particular sheet. So that is called a race condition. So if you want to avoid this means we need to use this semaphore. So mainly what the semaphore will do means it is like atomic operation. It sends notifications for the process. Okay, so you want to wait some time. If it passes signals means you can process your task. So like that it sends notifications to the process, and it also contains a non-negative value. Here we didn't use a non-negative value like minus values. We'll only use zeros and ones and the increment of that. How this semaphore will work means uh, if we are setting a method or we are using the method wait means it indicates, so it is in a critical section. So critical section means some other person is using the same file, so you want to wait until the person completes that particular task, then only you will receive that resource. Next, blocking means semaphore equals 0, so until get or receives the signal from the other process you want to wait. Next, exit means you will pass a signal, so based on getting the signal you can execute your process. So these three things we need to consider in semaphore. So we'll have the operations like wait and signal. So wait means it is less than or equal to 0. So we need to wait until receive any notification. So if you give or get the notifications like signals means you'll proceed for that. So to avoid the uh, race conditions, we'll use automaticity. Next, binary semaphore. So it is called as a mutex lock. So binary means we'll use only 0 and 1. So if it has 0 means you need to wait, 1 means you can execute the process. Next, counting semaphore. So counting semaphore here, how it performs means, so it doesn't have any upper bound values, above values like 2, 3, like that. So based on the resource count, if you have a 10 resource means based on that resource count, it performs the operation. So if you have a database means for that database, if some other person is using the same database means you need to wait. So it doesn't pass signal. So after getting a notification, you can use that database. Next, mutex and semaphores. So mainly mutex means it is a single process. Only one person can access it. So here we have a lock. So one person is using means that particular resource is locked. So after he completes the particular task, he can release that. So the access is guaranteed in mutex. In semaphore, multiple process signaling has happened. So multiple peoples are accessing the different resources at multiple simultaneous times. So it can be access the process or an event. So the main example for semaphore is produce and consumer problem. So empty means counting values in buffer slot. Nothing is there, but we are counting on that. Full means all the slots are filled. We need to count what how many slots are filled. So if there is any empty slot, so we have to find out in full if there is any empty slot, and in empty if there is any processes there. So we need to identify these two things. Here the main mutex thing what we are using is we are using the concept of zeros and ones. So we need to wait until other person completes it. If you'll get a signal, you can process your task. So the real world examples of the semaphore is thread synchronization. So multiple thread applications will be opened on your system. So based on the application priority or the resource usage, you'll use different things. Next, resource management. So how it manage the resources means if you're having a database means it provides logs. So by using a logging concept, it provides controls your databases and device drivers. So for every system it has different drivers. uh, okay, so for example if you are taking your system aids, you have different drive, E drive, C drive, like that, no? So based on the drive informations it execute your process. Thank you.